Hello students, in this session let us learn about representation of a complex number on a complex plane. We know that we can represent a linear equation in a coordinate axis or in a Cartesian plane. In a similar way, we can represent complex numbers on a complex plane. Let's see how do we represent that. Like how we take a Cartesian plane, let us take an xy plane where I consider my x-axis as real axis. So this is your real axis where you represent real part of the complex number. What do we do here? We know that a complex number is represented by z is equal to x plus iy, where x is the real part of the complex number and y is your imaginary part of your complex number. We know this, we have studied this in the previous session. Now let us try to represent this. As I told you, x is taken as, this is your positive x-axis, this is your negative x-axis. X is taken as a real axis where you represent the real part of the complex number on the real axis, and your y-axis, this is y, which is your imaginary axis. We write this as the imaginary axis. So imaginary part of the complex number is represented on y axis. Now let us see how do we represent. Suppose I take a complex number 2x or 2 plus 3i, and always remember children, whenever I write a complex number, now your x part represents the real part of the complex number, y part represents the imaginary part of the complex number. Now in this 2 plus 3i, how do I plot? What are your coordinates? Your coordinates is x comma y, that is 2 comma 3. So we are going to plot this. Suppose this is your 1 on x-axis, this is your 2, this is your 3, this is your 4. I'm just representing the positive x and positive y, so that for this problem we just require positive x and positive y axis. So if suppose I'm representing like this, where is 2 comma 3? You have 2 on x axis, 3 on y axis. So this point I will take it as 2 comma 3. So this represents your complex number. I draw a line from the origin. What is this? This line represents, always remember, the distance of the complex number from the origin. What is it, children? Distance of a complex number, of a complex from origin is always, what is this? This is nothing but your modulus of z. Why so? If you notice here, you know always the x coordinate is the distance of the point, the perpendicular distance of the point from y-axis, and your y coordinate is a perpendicular distance of the point from x-axis. So here 2 comma 3, when I write, this is the perpendicular distance of the point from y-axis, this is the perpendicular distance of the point from x-axis. So I write 2 comma 3. Now if I take this as a right angle triangle, because we know this as 90 degree, if you take Pythagoras theorem, here your r is nothing but 2 square plus 3 square under the root, which is also called as modulus of z. So you get this value as root of 4 plus 9, which is root 13. Root 13 units is the distance of this complex number from the origin. So this is how we represent a complex number on a complex plane, or we call this as argand diagram. Now how do we write? Like I have written a complex in the form x plus iy, so it has come in the first quadrant. Why? Because in the first quadrant x is positive, y is positive. Similarly, in the first quadrant you will write a complex number if it is of the form x plus iy. What about the second quadrant? Look at this. In the second quadrant your x is negative, y is positive, so your complex number should be of the form minus x plus iy. And in the third quadrant your complex will be of the form minus x minus iy. In the fourth quadrant it will be of the form x minus iy. So you can notice, by looking at a complex number you can tell me in which quadrant it lies. Always remember, x plus iy, the complex in the form x plus iy will be represented in the first quadrant, x minus x plus iy in the second quadrant, minus x minus iy in the third quadrant, and x minus iy in the fourth quadrant. Now you understood. If I give you a complex number, you can tell me which quadrant it lies. Now in the similar way, we have few of the important terms related to the complex number which you need to study here. What are they? This what we got is modulus. Now we have to find something called amplitude, or we call it argument also. Amplitude is nothing but the principal value of the argument. Now this theta is the angle made by the complex number with respect to the positive x-axis. Always remember, what is this theta? This theta is the angle made by the complex number with respect to the positive x-axis. So wherever it is, you are going to measure that angle from positive x-axis, not with respect to any other axis, only positive x-axis. Now in this complex, if you want to find, if you notice here, this distance is 2 units according to the scale what we have taken, that is 1 centimeter is 1 unit, and here it is 3 units. Now if you want to take the theta, that theta can be written as tan inverse of modulus of 3 by 2. So that is nothing but, always remember, your theta what you are taking for a complex number will be of the form tan inverse of y by x. Is it same in every quadrant? No. This will not be same in every quadrant, it will differ. How will it differ? Let's check. In the first quadrant, your theta is directly tan inverse of y by x. You can notice here, children, it is tan inverse of y by x. In the first quadrant, it is tan inverse of y by x. Now we have seen argument of z. What is argument of z? We write it as theta is equal to tan inverse of y by x. Is it same for all other complex in different quadrants? No, it is not same. You will write theta is equal to tan inverse of y by x as the argument only if the complex number is of the form x plus iy, which lies in the first quadrant. What if it lies in the other quadrants? Let's see here. If it is in the first quadrant, we have written tan inverse of y by x. This is the argument. What do we call it? This is the argument of the complex number. So try to understand, it's very important. This is the argument. Now what if a complex number is here? If the complex number is here, the distance will be z mod z, which is always positive. We write like this. Now you are measuring angle with respect to this. Now notice, children, suppose this is a complex number where this is your minus x and this value what you get is your y. Now here, if it is making an angle phi, let's take it is making an angle phi. Here we had taken theta. To avoid confusion, here I have taken phi. So what is the argument here? Here argument of this complex number, argument of this complex number, argument of z, I write it as pi minus phi. Why it is pi minus phi? I have told you when we were measuring the argument, or when we were discussing about the argument in the first quadrant, we discussed that always you are measuring the argument, that theta, with respect to positive x-axis. Now if you are measuring from positive x-axis, it is making an angle phi with y-axis. So if you are measuring from here, what is this? Entire angle from here to here is pi, minus phi will give you this angle. So this angle what we are measuring, that is pi minus phi. So here what is the argument, children? It is pi minus phi, or you can write pi minus tan inverse of y by x here. So I will write, it can also be written as pi minus tan inverse of modulus of y by x. This is your phi value. This is your theta, basically argument of z. Theta here is pi minus tan inverse of y by x. In a similar way, let's see here what happens. This is in the third quadrant. In the third quadrant, when you're measuring, children, it will make an angle. Suppose it makes an angle phi here, then how do you represent? You take a complex number, it makes an angle phi. So if you are measuring it, how do you measure it? When you are measuring from the real part of the complex number, you will write it as minus pi plus phi. So this is argument of your complex number when it is in the third quadrant. And what happens in the fourth quadrant? You can see in the fourth quadrant, it is an image of your complex number on the x-axis. So in the fourth quadrant, if it is forming, we directly write it as minus theta. So whatever angle it is making with the positive x-axis, you also know about the conjugate. The conjugate makes an angle negative theta because it's an image of your complex number. So whatever angle it makes with the x-axis here, we take it as minus theta. So you know argument and the modulus in all four quadrants. Modulus remains the same. It is root of x square plus y square, where your complex number is in the form x plus iy. And when it is in different form, x minus iy minus x plus iy, in every cases you take value of x, value of y under the root x square plus y square is going to give you mod z. So mod z will not change in any cases. It is because you know square of a positive negative number, it's still going to give you the positive value. So mod z will not change, but your argument is different in different quadrants. So based on the format or based on the form of your complex number, you will decide what is the argument.